Class 9. Children, I am physics teacher. I am experienced teacher from CBC Port for 11 years, and I have completed near about 20 years in West Bengal Board of Secondary Education. Now I am thinking to make physics very easy for all of you. We are going to upload video for 9, 10, 11, 12 and NEET gradually. I shall try my best to teach you in easiest way so that you can comprehend the subject very easily. Now it is my introductory class, that is class 9, lecture 1. Today I am going to discuss to define some scalar quantity and vector quantity in this physical world. First of all, I am going to define the following terms associated with this chapter, and one by one I shall introduce you with the lecture 1, lecture 2, lecture 3. In this way I shall complete the chapter force and motion. Now first, we are living in a physical world, so every day we face some experimental physical quantity, that is the scalar quantity and vector quantity. Now you may ask these questions: what is scalar quantity? Scalar quantity is a physical quantity. It is defined by only magnitude, not direction. As for example, mass, speed, density, volume, distance, work, power, etc. Similarly, we face some vector quantities. As for example, displacement, velocity, acceleration, retardation, electric intensity, magnetic intensity, like this. After that, we are going to define what is distance and what is displacement. Very fundamental quantity in physics. When we are going to introduce these two terms in your first chapter, second chapter, that means what is the distance? Suppose a particle moving A to B in this way, A to B. Different path you can reach from A to B. A to B you can reach path number 1 and path number 2 and path number 3. If I ask you what is the distance, distance is total path covered by the body. Path may be different. But what is the displacement? Displacement is the vector quantity, that is the shortest distance between the initial position to final position. Or certainly it is a vector quantity. So there is no motion where distance is less than displacement. You will not get an example where the distance. Suppose a body moving in a semicircular path. If I ask you what is the distance, you will tell me AEB, that is the distance, and you will tell what is the displacement. Displacement is AB. This is the example. That is the diameter of this semicircle will give you this displacement, but half of the circumference of the semicircle will give you the distance. After that, I am going to define you what is the speed. Now, speed is what is the total distance per unit time. So, to define the speed mathematically, first you calculate distance. You calculate distance, then by time. Okay. After that, children, this speed, distance by time. But if I want to calculate velocity, then velocity will be displacement by time. Displacement by time. Suppose you are throwing a body upward direction, then catching it again after certain time. Displacement is 0, so average velocity is 0. But this speed is not 0, distance by time is not 0. So velocity. Suppose a body moving in a circular path. A body moving in a circular path. Then at A and B and C, every point speed of the particle is 10 meter per second, but velocity is 10, magnitude is 10, but you see tangent at the point A, tangent at the point C, and tangent point at the point B is different direction. So I should say that speed is 10 meter per second, but velocity is not constant due to variation of direction. So whenever we are considering velocity, we must consider in mind that direction is very important part. So to deal with velocity, direction is very important part. So whenever you going to calculate the vector quantity, always remember that direction is very important part. So don't forget about the direction. Okay. After that, I am going to define you with acceleration and retardation. Acceleration and retardation. What is acceleration? Acceleration is acceleration means maybe uniform acceleration. Suppose a particle moving with velocity 10, after 1 second velocity 12, after 1 second velocity 14, after 1 second velocity 16, after 1 second velocity 18. It is clear to us that every 1 second velocity increase by 2. So I should say gradually velocity increasing. With time velocity increasing. That means slope tan theta of v take out tan theta. That is the acceleration. The slope constant. Slope of v graph will give you this acceleration. The acceleration is defined like this. Acceleration A, or some books F, equal to velocity final minus velocity initial by time. What is V? V is the final velocity. Use the initial velocity. T is the time. Remember, if a body stops, then V equal to 0. If body starts from rest, E equal to 0. If body starts from rest, if a body starts from rest, then E equal to 0. Now E equal to velocity change by time. So what is the velocity change? The displacement change by time. Again for rate another time. So to define the unit of acceleration, we see our dimension is coming L to the power minus 2. Or the unit of time come twice to define the unit of acceleration. Similarly, what is the retardation? Now initial velocity 18, after that it is 16, after that is 14. So we see velocity gradually decreases with time. So we should say this is the retardation. Retardation means rate of decrease of velocity. Now it is clear that now we are going to revise the lesson first. What is the scalar quantity? I have told you. Scalar quantity is a physical quantity having magnitude only. Vector quantity having magnitude and direction, and it will follow the laws of vector addition. And what is the displacement? Displacement is a vector quantity. If we consider a moving particle, the shortest distance in between initial to final point of the moving particle in a particular direction is the displacement. Displacement per unit time, that is velocity. Distance per unit time is the speed. Now there are some conclusion. What is the acceleration and what is retardation? If a body moving with gradually increasing order of velocity 10, 12, 14, 16, then 18, then we should say the velocity gradually increasing at the rate 2 meter per second. So 1 is the 2 meter per second velocity change per unit time. This is the uniform acceleration. On the other hand, if velocity gradually decreases 18, 16, then after 2 seconds 14, then 2, 12, then 10, then I should say it is retardation. Now I am going to consider some equation. I am going to derive some equation with the help of this concept. Let us consider first a particle moving with initial velocity u. Initial velocity u and final velocity v for time t. So what is the acceleration? You know, acceleration equal to velocity change by time. Acceleration equal to velocity change by time, or if you cross multiply, you are getting at equal to v minus u, or v equal to u plus at. This is the first equation of motion. First equation of motion. What is v? Final velocity. What is u? Initial velocity. A is the uniform acceleration. K is the time allotted. Now, final velocity v, initial velocity u for time t, body covers displacement s. What is the displacement? S. Initial velocity u, final velocity v is final velocity. It is initial velocity. So, what is the displacement for the particle? Initial velocity u, final velocity v for time t. What is the displacement? Children, first to consider what is the velocity after 1 second, that is u plus a. Here a is the acceleration. What is the velocity before 1 second from the end of the journey? Then it is v minus a. After that, you consider what is the velocity after 2 seconds from the initial journey. What is the velocity before the end of the journey? In this way, if you consider, you see average velocity equal to u plus at plus v minus at by 2. That is equal to u plus v by 2. So we may assume that, we may say that although initial velocity is u, final velocity is v, as if the particle moving with average velocity u plus v by 2 for the time t. In that case, displacement s equal to average velocity into time, put v equal to u plus at. So we have s equal to ut plus half at. Is very important, this equation for numericals. We will face some numericals with the help of this equation. S equal to ut plus half at square. If the body moves with retardation, then instead of plus a, you use minus a. Again I am repeating, initial velocity v, final initial velocity u and final velocity v, acceleration a, time t. If you cross multiply, we are getting an equation v equal to u plus at. If body starts journey with initial journey from rest, then you consider u equal to 0. If body comes to rest due to retardation after certain time, then v equal to 0 and a equal to plus a, not plus a, it will be minus a. Okay. After that I am considering, suppose particle initial velocity u and final velocity v. Initial u, final v. Body moving with uniform acceleration. Then can you tell me what is the velocity after 1 second? U plus a, by using v equal to u plus at. What is the velocity before 1 second from the end of the journey? From v minus a. After 2 seconds, what is the velocity? U plus 2a. What is the velocity before 2 seconds from v, before the end of the, when the body finishes, then v minus 2a. So in this way, if you continue, then you will see body moving with average velocity u plus v by 2. So we should say that average velocity of the particle u plus v by 2 for time t. Then what is the displacement covered by the body? U plus v by 2 into time. So that is equal to displacement. So displacement is equal to ut plus half at square. If you put v equal to u plus at. So we have covered what we have taught today. We have taught today two things. One is physical world. Physical world in physics we are measuring so many physical quantities. Physical quantities in all level can be classified by two groups. One group is scalar quantity, other group is vector quantity. Now scalar quantity means some physical quantity having magnitude only, as for example mass, volume, density, distance, speed, so many things, watt power, like this. And there are some physical quantities having magnitude, direction, as well as it will follow the law of vector addition. As for example, displacement, after that velocity, acceleration, retardation, momentum, force, electric intensity, magnetic intensity, like this. Momentum I have told already. Now question is that after that I am going to defining what is the rest and what is the motion. If a particle does not change its position with respect to time, that is the particle is at rest. And if the particle changes its position with respect to time, then it is a motion. Clear? But you may always remember there is no absolute rest, no absolute motion. It purely depends on frame of reference where from this particle is observed. Suppose you are observing something at rest, but other planet you observe the same thing that is rotating, moving. In this way you can see difference. No absolute rest, no absolute motion. After that I am going to tell you one thing, that is what is the distance. Suppose a moving particle going from A to B, defined path it may go A to B. So total path covered by the body, that is the distance. Shortest distance from the initial point to final point is displacement. Displacement cannot be more than distance. Clear? Displacement cannot be more than distance. Now you consider different types of motion. Uniform motion, where there is constant velocity, body moving in a part. Constant velocity means direction wise constant and magnitude wise constant. So if the body consider displacement s and time t, then velocity equal to displacement by time, but speed equal to distance by time. After that, now we are going to consider average velocity. Okay, now let us consider average velocity. What is the average velocity? After that I am considering average velocity. What is average velocity? Average velocity. Suppose you consider total displacement in two parts. One part is d1, other part is d2. A to B total displacement. Part A to C is d1 displacement and part C to B is the d2. Now the moving particle moving with velocity v1 for AC, v1 for d1 for AC, AC for given velocity, and d2 displacement covered with velocity v2. Again I am considering, remember, A to B total path, total displacement divided into equal to divide parts. One is d1, other is d2. d1 displacement, body moving with velocity v1, and d2 displacement, body moving with v2. Now time for b1 displacement equal to d1 by v1, time for d2 displacement d2 by v2. Now average velocity equal to total path, total displacement d1 plus d2 by total time d1 by v1 plus d2 by v2. Again I am repeating, total path AB divided into two parts d1 and d2. First part, the body moving with velocity v1, second part, body moving with velocity v2. Now I am considering time for the first part, distance, first d1 distance time equal to d1 by v1, and for second displacement it is d2 equal to d2 by v2. Now what is the average velocity? Average velocity d1 plus d2 by total time d1 by v1 plus d2 by v2. So we are considering what we have taught today. We have taught definition of displacement, distance, scalar, vector, acceleration, retardation. After that I have derived equation v equal to u plus at, s equal to u2 plus half at square, and average velocity I have deduced d1 plus d2, d1 by v1. Next video, next lesson, you consider the motion regarding graphical representation motion, v square equal to u square plus 2as, and what is the displacement covered at the teeth second. And next video, please subscribe if you are interested to continue this video lesson. Then you wait for next video that will be uploaded on that. Okay, thank you.